try to explain what the code does, and I'm going to show you some things that I think are substantially more important than wasting time with that.
Okay.
Right?
Cool.
So, to kick it off, how many people here know what asynchronous code means or what it is? Anyone want to try to give this a shot?
It means
What are you guys give it a shot?
if you tell JavaScript to do something or multiple things, it doesn't mean that what goes in first will come out first.
So you want to give a shot?
Yeah, we do it so that you continue while someone else is waiting. Like let's say you're fetching routine. The first function is fetching and doing a database call, which takes a while, can take a while, and another part of the code could be running also. I don't want to say in parallel, but kind of in parallel. Like in asynchronous code, this routine has to finish, and then this one can pick it up, and then that one fit. And there's a lot of downtime where the processor's not necessarily doing anything. We're just waiting for database assets. So asynchronous allows multiple, you might say threads to run, but it's not really necessarily threads, OS threads, to run at the same time.
I ran into something like that at work where...
Well, before you respond to me, make sure that what I said makes any sense through the filter. He's the filter.
Yeah, I actually think that's very good. So we can keep it a lot simpler. Without writing asynchronous code, we have very poor utilization of our machine. Right? So if we write asynchronous code, our machine can concurrently, that's the word you're looking for, can concurrently do more than one thing at a time. So perhaps you can send a request to 2 websites and wait for whichever one returns first before you start processing. And we're going to take a comment, and then I want to show some examples of code that's not concurrent and show you why JavaScript is different and why we have to learn this, but you wouldn't if you were learning something like Python, which we may be teaching shortly.
So at work, we use PHP on the server, and I was tasked with developing like an app that has all these API calls to all these different services, like Rxjs to kind of check up on what's being hosted on a particular server. Then it does like a DNS check to match the records and things like that. And that's when I learned like PHP, nothing works. Like if any other thing is requesting something on that same block of code, it just won't execute at all. Whereas when I was working with like something like Node.js, anything can run concurrently, right? It can just run at the same time. I don't have to wait for this long block, this huge function to just execute. Whereas in PHP, this huge chunk of code needs to run before anything else is being called, and it's like a big pain.
So Node is, I guess, doing that. That's one of the features of Node, right?
So stepping back a second, right? We're going to get into a lot of this. Let's take a look at this code.
Quick question: does anyone have a mouse? It's an extra mouse.
You can use mine.
The savior.
Yeah, if you grab me one.
First mouse.
Are you needing a mouse?
Okay.
No.
Oh, okay. No.
He's already got it.
I communicate with my machine telepathically.
Oh no! Anyone else have a mouse?
Mouse down.
If I give him a mouse, I'll lose it.
Still alive. A mouse survived everything.
Does anyone have another mouse?
Okay, so we're gonna loop back around and we're going to do plenty of looping today, but we're definitely gonna get back to the points that were made earlier. I want to show some other examples of code, and we're gonna look at some Node examples shortly after. We're waiting for one other person to get back from the lunchroom now. Here we go. Boom.
Boom chakalaka.
That'll work. Thank you, my friend. Yep.
Gotta have it.
Always value code. Okay. So this is code here. This is typical code. You'll see this in every language. I showed you Perl because this is the way that Perl writes a basic little program that opens a file. Yeah. Right? So we can see here that we've given it a file name. I'm going to make that a little bit bigger for those of you that don't have microscope eyes or telescope eyes.
I can see it pretty good.
You you young spring
get
chicken.
back.
Yeah. There we go. Okay, so here's what we're doing. Look, we are opening this file name. That's the location of it, because Perl, when you think of it, you should always think stuff that runs on Windows. Joking. And what we're doing here is we are opening this file for writing. Then we are writing to this file. Then we are closing this file. Then we're printing this, right, to the screen. So in this method of writing code, this is, by the way, this is almost exactly how Python would look, right? And I have a Python example to show you for those that insist Perl is somehow fundamentally different. But this code here is called synchronous. So you can literally follow it from the top. The crap higher up in the page runs first. The crap lower down in the page runs last, right? This is also the way PHP works, which, by the way, is roughly based on Perl. Except it's dumber, and it's made for dumber people. I do like Perl better than PHP. But,
Good example.
Look, it's technology. We don't have the ability to pick what we want to use. So here's an example of Python, right? This is the very same type of thing. And what I'm just trying to communicate here is that it's all pretty. Now the Python guys are very artsy. That's why this is gray on white instead of black on white. Not sure what they're going for.
Why has it got so many comments?
I have no idea why it has so many comments. That's the Python 3 example. So here we're opening a file, right? We're saying for I in range 10. That means we're looping through 10 different things, and we're saying this is a line. We're printing that out to the file. Then we're closing the file. The stuff at the top runs first. Stuff at the bottom runs last. This is the basic method of writing synchronous code. It's very, what we would say is imperative, right? You're telling the machine what to do and in what order to do it. Now, Node is substantially different, right? This is not a Node example, but this is actually the Node API, right? So if we look here, we're going to see FS. We're going to see two different methods here. Two different things I want to focus on. I want to focus on those two, right? So we're going to see fs open and fs open sync, right? So the sync method, we don't really use that in Node, right? You can, it's there, but we always use this method above, fs open. You actually have to write more shit to do it the wrong way, which every other language does it by default. The difference is fs open, right, is going to go in the back, it's going to try to open a file, and then it's going to immediately start running the next code before that file is even open. So what if you're opening a file that's on a network, if it's in, you know, Bangladesh or whatever? That could be a costly process to actually retrieve that file or open that file or find out if it exists. All of that type of stuff takes time. So fs open is going to see this little thing called a callback. It's going to call that code whenever you get the result of that open operation. So you're going to say open this file, and when you've got it open, then execute this code here, callback. So you're creating actions that get triggered based on the success of whatever you're wanting to do. Right? Open this file, and if you open it successfully, do this. If you don't, do this. After you have the file open, try to write to it. And if you can write to it successfully, then do this. If not, do this. When you have all of those actions sequenced, Node can do more things with it. And now it gets really into the crux of what Node is doing. And this book has a lot of text over a very, very simple concept. And it doesn't come out straight and introduce you to the concept. The concept is very simple. It's called an event loop. And it's absolutely critical that you understand something about it, even if you don't understand all of it. The event loop is actually what makes Node different. All of these methods here are not, in and of themselves, an innovative idea. All of the other languages, right, even if you're on PHP, have most of these methods available, right, if not all. Some of them have all. But the thing is that those languages don't run in an event loop. So those features are not core. But I guarantee you, if you go to you go to Google and you type in PHP event loop asynchronous programming, you're going to find someone who's created a framework that that caters to that need. Maybe less likely in PHP because, again, it's made for a different group of people. But certainly in Python has a framework called Twisted. Perl has a framework called Po and Async.io. And if you're writing C code, you can actually use the very same stuff Node is written in. All of these languages have bolt-on event loops, right? And all of these bolt-on event loops bring these asynchronous methods with them. Because when you have a bolt-on event loop, you now can do more than one thing at a time. because you can say, here's my callback. Something's got a callback when you have success, right? And the event loop is precisely the thing that's going to call that. So if you have something that you want done and you give it a callback, the event loop is the piece that's handling the machinery in the background. That's saying, okay, when this is done, I need to immediately, in the next run of the event loop, call that. Right? So that's how the plumbing is working.
Yeah, but if you just do fs open and it's off, checking that file in Bangladesh or whatever, and you is something else typically? Oh, I see. Your callback is reaching out.
Right. It has like the finished product.
Okay.
And then it'll do whatever needs to be done. Right. I don't know.
I'm going to try to field all of the questions and ask new questions to different people, just to keep things moving, and because I want to do at least something useful before the pizza, the feast, if you will. So I believe your question is simply what happens if the file in Bangladesh is never open?
No,
Is that what you're getting at?
not necessarily, but if it is open, it needs to be, whatever called it that wants it open, it's other code, it needs to be notified. Either, he was saying his callback notifies.
It's not notified. It's synchronous. Are you asking about synchronous code or asynchronous?
Asynchronous.
An asynchronous code is the callback, right? If that's what you're asking, the answer is simple. You're providing the callback, the event loop notifies the callback, I have the result, and then your callback is executed.
Okay.
Yep. Now let's talk about synchronous code. Let's say you make that request to Bangladesh in synchronous code. Let's say that file, that request is taking forever and ever, right? What happens?
Time out.
Here's the answer. The answer is you don't know what happens. Right? That's one of the problems with synchronous code. If you're writing synchronous code and something is waiting, it could wait indefinitely. There is no guarantee you'll ever return, right? If you write in synchronous code, let's say you write something here, right? You say, while true, loop, 1. When is this ever going to run? The printf-h, never. It's never going to run. It's the same way for the people that implement the libraries. They have to go above and beyond to say, while I'm waiting, you know, if I expire 5 seconds or whatever, timeout, and return to the caller. Because there is nothing that makes that thing return to the caller if that open doesn't work, right? Okay, so that's synchronous code, that's asynchronous code, that's callbacks. Callbacks are very simple, right? In normal synchronous code, what you're doing is you're essentially saying, do this, then do this, then do this, then do this, then do this. The method of execution is top-down. It's the way it runs. In asynchronous code, the method of execution is not top-down. It's actually from outer to inner, right? So let's look at his code here. Here we go. Bada boom. Right, let's see here. This is a request type. This is from his gossip example. So he has one where he's creating like a little messaging protocol. And we're going to look at this, and what we want to see is this code here, this nesting. This runs in the middle, right? So it's going to run this code outside, request type, whatever request type is going to do. It's going to go do its work. And then it's going to call this callback, which takes nest, message, and source, and executes this. So we know that if we see the fat arrow here, what does it mean? Who remembers?
It's a function.
It's a function, right? It's the syntax for creating an anonymous function. So when we see the fat arrow, we know we have a function. That function is the callback, right? We are calling request type, and we're providing it this callback. Whatever request type is doing, at some point, because it has a parameter that is a function, it's going to be using that. Stands to reason. You should always be questioning that type of thing. If this function takes a function, when is it going to call it? Because it's not doing it for shits and giggles. So it's either going to call this callback, nest, message, and source, on failure or on success. So what I want you to see here is, in the other examples with Perl and Python, we execute from the top down. It's very simple. In this example, we execute from the outside request type to the inside. And if this guy here did something that required a callback, it would go even further in and further in. There isn't an example of that up here, but we can certainly create one and look at one. If we go back to the Node API, we have an asynchronous method for opening a file. We have an asynchronous method for writing a file. All of that would create a different tier inside of that code. right? So you work your way from the outside inside. And on asynchronous code, we're going to run request type. We're not going to run this callback until we have success. We're certainly going to run this request type before we call this one, right? So we have request type, callback, request type, callback. When we run this request type, we're going to hit this one next. This will be the next piece of code we run. And on the next time we go around the loop, right, if we have the result, we're going to start calling the callbacks. That's how you think. And if we don't have the result, we're just going to wait for the next iteration of that loop. The event loop in the background keeps churning, and the callbacks are the message for the caller request type, right? To either post that back on the event loop, say we're done, we have success, or we have failure, right? Callbacks are very transparent. We provide them all at the end. What we're going to see here in a minute after we eat is how promises do it. Promises are a different way of writing code, and it's a lot cleaner method of writing code. It handles errors a lot better, and it doesn't have this side effect of having to look outside to inside, because it tries to put it back in, you know, your court of working from the top down. So a callback is do this, then do this, then do this, then do this. Rather, a promise is do this, then do this, then do this, then do this. But in a callback situation, we're doing do this, then do this callback. And if something inside does a callback, you're going to say do this, and then on the result do this callback. And you just keep on doing it. I'm going to have some examples up here when we're done eating pizza, and we'll go through some just node
In
code.
general, is there a reason to use a callback instead of a promise, or can you almost always use promises?
You can almost always use a promise, because those are likely what the library authors are using themselves. That wasn't Node, like this, which is Perl. Actually, no, this is actually PHP. It was mentioned earlier, we had it pop up that PHP couldn't do this, and I wanted to go back to what I said earlier. PHP certainly can do this. There's something with PHP called React PHP. It provides the event loop for PHP, gives you asynchronous functions for PHP. This is an asynchronous request, HTTP request for PHP. Most languages have something like this. If you're not using Node and you're just here because you want to learn programming, what you would do is simply type into Google asynchronous programming, event loop, and then whatever language you're looking for, and it will suggest to you a library for that language. Okay, so this is the one for PHP, and generally speaking, if PHP's got it, everyone has it.
Huh.
Okay, so let's look at here. This is an example of what we call callback hell, right? Now, some people may not like the term hell, but nonetheless, it's useful to show. What's going on here is that each time we have an indentation in this, well, this is an especially malicious example, but generally speaking, each time we have an indentation, we have one more callback inside of the code, right? Because we indent the body of a function. We don't indent the function itself, unless you're crazy. We usually indent the stuff inside the function. So when you have a different indentation level, you're usually showing that there's an additional function. If you have an additional indentation level inside of a function, it's because you have a function inside of a function. Generally speaking, the largest reason why you'll do it, certainly not the only reason, but the big reason, is because the function inside of a function is a callback, right? So if you see this thing going and getting indented further and further and further, usually it's a callback, right? So if we look here, we have this. This is the callback, widths.forEach, and then we provided this thing here. This is actually not a callback. This is the continuation that we went through earlier, right? But certainly, this whole process of it's going to call this function you provided. Okay? And then if you go down here, we're saying files.forEach. For each different file, it's providing it a function that takes a file name and a file index. And then what it's actually doing is it's opening the file, presumably. Error writing to this file, or identifying this file. Here you go, GM. I don't know, they don't have the definition of GM, but my guess is GM is opening that file. Right? So GM is taking the source plus the file name, and it's calling, after it does that, it's calling .size on it and some other stuff. But the point is that this callback shape, right, as you get deeper and deeper into it, it's representing to you an additional level inside of that asynchronous code. So we're going to look at different ways to solve this, right? And you can see that again here, right? Let's look at this code here.
Evan, before you solve it, maybe state what the problem is. Is it
The problem
that
is
it's taking more memory because it's in the stack? It's stacked like that, or
No.
because it's hard to see what the code's doing? Because
Hard to see what the code's doing.
Okay.
It's hard to maintain the code. It's hard to see what the code's doing.
Okay.
Right? Generally speaking, you want something to be sequenced in time because humans are really good with it. It's all we've ever known. Or something that is somehow related to a spatial recognition system, right? So you can spatially recognize that the shit at the top of the page is going to execute first. The stuff at the bottom of the page is going to execute last. That's arranged pretty logically, right? If you read a book, it makes sense that the beginning of the book is on one side and the end of the book is on the other. If I mix up all of the pages, even if they're numbered, it's going to be not so much fun, right? So the whole concept of reorganizing the way callbacks work is very close to that. You want one side of that book to be where you start and the other side to be where you end, right? That helps you get through it a lot easier. And that's what these methods of organization do. Callbacks get the job done, right? But it's a complex way of doing it. It's a very fundamental way in JavaScript. You would have seen this very often earlier on, but those days have long since gone, and now we tend to use different things that take care of this problem a little better. So we look here. Actually, you know what? I don't think we need to see 10,000 different ways to do this. Let's go over here and I'm going to show you some other examples. This is from javascript.no. This is the one I want. This is the Mozilla development blog, right? This is an example too. We have do something, and then it takes a function and a result, and it calls do something else, which takes a result and a callback, which takes a new result, and then we have the do third thing, which takes the new result from that function, and it calls the function with final result. That is slightly difficult to follow. This is an actual example of how callbacks really do work though, right? Do something is asynchronous, you call it, and when it's done doing something, it calls this, which is your callback, right? Then it's going to call do something else, and that's going to take the result, right? And it's going to take another callback. You go one more level down, do the third thing, it's going to take a new result and your third callback. And each time you see that indentation level go further and further in, that represents like I said, you're working from the outside inward, right? It represents a different step in that process. Okay, but this is what we really want, right? And these are called promises, and we're going to look today at how to implement some of them. So what we want to do is something like this: do something dot then, and we give it the callback, and then we say dot then, and then we give it the callback, and then we say dot then, and we give it the callback. And we want that because now we don't have to go through that whole pyramid code, which may not be hell, but it's certainly not enjoyable. And we also have brought back our mode of operating where we start from the top and we work our way to the bottom. There's one other advantage to this, and that's checking errors. It sanely checks errors. So you can check errors over all of these steps. And you can say if anything in here throws an error, I want to catch that error. You can't do that with callbacks, right? You can't do it with callbacks because the error is inside of the callback code. Your try-catch block doesn't catch it. But in this one, it will, right? You have your own method of capturing those errors inside of the promise.
Do promises deal with all callback issues, and we're kind of getting away from callbacks, or just in this situation?
Yeah, we certainly are getting away from all callbacks.
Okay.
If you were writing a library today, you wouldn't expose callback API. You would, generally speaking, unless it was a high-performance library, you would expose a promise. Right? You would provide something like do something here, and then your client, whoever is using that library you're creating, they would essentially take that function and call .then from it. So most of the higher level libraries are using promises, right? And at this point, we can use the async await, which was the question that we hit on earlier. Right? How do we do this today? And I said, look, the promises are a great start, but we don't even use them anymore. We tend to use async await in the Node.js side of things. And on the browser, right, we talked about this earlier too. I said in the browser we write code that doesn't get run yet because the browser lags, And we use something that actually takes that code that we write and it transpiles it. Takes it from modern JavaScript to stupid old JavaScript, right? So we do that because we want to be able to use the latest and greatest features. So we take and we write new code with async and await, and then we compile it down for browsers too stupid to understand it. Right? So generally speaking, we use modern ES syntax imports, we use async await, production JavaScript, we'll use all of those types of features, and then we run it through a process that takes it and dumbs it down for everything else, the distribution part. Okay, so this is our goal here for this class, right? We want to understand this, and we're also going to quickly look at the async await stuff. But I wanted you to understand the problem. The problem is style, hard to follow, hard to catch errors, all of that type of stuff. If you have this guy error out here, how do you make sure that you catch it, right? You have to catch it from do something else. And then if this guy errors out, where do you catch it? You have to catch it from do something. So that becomes a pain in the ass. You want to essentially tell your users you can catch all of the errors in that process. And promises make that doable. Okay, so as a note here, I told you I didn't really enjoy the way this book is going over this stuff because this book gets lost in the weeds when they talk about their applications of this stuff. So in the book's example, they're doing like a gossip protocol messaging thing, and I really think that that's insane. So we're going to use the same amount of time, and I'm going to actually show you how promises are implemented so you guys can have a more thorough understanding of them. And it's also somewhat important to say that if you don't understand promises and how they're implemented, it's pretty much fine. Because you're only going to be writing your own promises, implementation of them, if you're either writing a library that does this, or if you're writing a library that's using promises, where you really have to know. Other than that, other than those two fields, writing something that exposes promises and writing a library that handles them, what your API is going to look like, what you're going to be doing, is going to be pretty much just this. All you're going to be doing as a user is calling then when something is successful, and calling catch when you want to catch your errors. So this is the takeaway. The takeaway is we have a lot of time. I want to show you how they work. But at the end of the day, this is their magic word. Catch and then. And all you got to do is follow that sequence. Then, when you want to sequence actions, after you do this successfully, then do this successfully. Why are we breaking it up? We're breaking it up so we can run code asynchronously, right? This, then this, then this. That's how it flows. It's very Englishy and it works. Catch for your errors.
That's the syntax for promises and for async await.
No, async await is slightly different, and we're going to go into that at the very end, right? But I want you to realize that because we can scare you away with a lot of this crap, and this book is really, really fantastically great at scaring people away with a lot of crap. I don't want to fall victim to it too. All you really have to know is the thens and the catches. Right? When you're using a promise API, then and catch. Okay, so how do these promises work? Right? Let's demystify some of that voodoo, because it's better to demystify this voodoo than to explain the gossip protocol or gossiping and whatever else he's got in there. Promises have different states: pending, fulfilled, and rejected. Very simple, right? It's very simple. If it's done, it's fulfilled. Nothing more to do. If it failed and you throw an error, it's rejected. And if it's somewhere in between, it's pending. You send the request to the server in Bangladesh, you don't have the response back yet, that promise is pending. Right? Those are the promise's internal states. Come on in. Welcome. So what we're doing here is we have a variable called state, and it stores this. This is a higher level overview, but by the way, this is we're going to be building, as we look through this, a functional implementation of promises. This is how I learned them when they came out, right? So I hope it helps make sense to other people. We have a state here. It's got pending, fulfilled, and rejected. We have a value, right? Store the value or error once fulfilled or rejected. Promise has no value until it's fulfilled or rejected. Then the value gets sent to whatever you're calling back, right? And then your handlers. When you say .then, that's all the crap that becomes your handlers. So state, value, and handlers. That's kind of like the core of the promise. And by the way, if anyone is interested in this, this is under Promise.js implemented, right? Which is supposed to help you understand how these things work. Okay, so we have two transitions, right, that we're going to go through. One of them is from pending to fulfilled, and one of them is from pending to rejected. You only got to go down one of those paths. You create a promise, it's got to be pending. There's no pre-pending, it's pending, right? And then when you resolve that promise, you're either resolving it to success or you're resolving it to failure, or rejecting it to failure, if you will. Those are your options. So we essentially create a function. And all that function does is when we call fulfill, it changes the state to fulfilled, and it sets the value to the result, whatever you provide that function. Same thing here with reject. Reject changes the state to rejected, sends the value to the result. These functions change the state of the promise. We went through that earlier, right? We talked about what state is. State's where you store stuff. This promise knows something. It knows what its value is, and it knows what state it's in. And these two functions can be called inside of that. Node is going to handle it, or the browser is going to handle it. Bad stuff happens then. So the user that handles that error should be the one that interfaces with that library. If you're going to handle the error that you can't communicate with Bangladesh when you open that file asynchronously, you're going to be the one that wants to do that, right? You want to say, okay, I can't open up the file in Bangladesh. Maybe I should open up the file in Canada. You know, maybe that's my backup. You handle that error there. So you put that in a try block, right? If it errors out, you catch it. That's all there is to it. So this function here, this resolve function that we're adding to the promise, tries it, and then if something doesn't go right, it catches that error. But what does it do? It calls reject on that error, right? So this is your JavaScript functionality for catching the error. This is internally how a promise works. But internally, a promise rejects the error by calling its own internal rejection function, or by calling its internal resolve function, fulfill. Right? Now, let's go back. You can see it here. That's what reject does, right? Two things. Who wants to hit those two things? It's right there. We're changing one thing and we're setting one thing. Change a state, set a value, precisely. So we change a state and set a value if we catch an error, and if we don't catch an error, we change a state and set a value. That's what resolve's doing for you. Depending on whether or not you catch an error, you change a different state. You set the same value anyway. Okay, so now we have another function called getThen, right? So okay, so this is what this guy's going to do. getThen, this is just a really safe and cheap method to determine whether or not you have a promise, right? If you have a promise, then you're going to say the type of the value, whatever you have, you give it to getThen, is going to be an object, right? That's what they're calling there. They're calling type of value equals object, and it's a function. Then what we're going to do is look at that value.then. We talked about a promise, and I said there are two things you're going to be using as a consumer of a promise. One of them is catch, the other one is then, right? You as a user of a promise are going to be calling then, and you're going to be calling catch. This guy here, getThen, it's going to pull the then method out of the promise if it's a promise, if it has a then method. Right, that's all that's doing. So we're going to look down here. Right? So this one here, doResolve, it takes a potentially misbehaving resolver function and it makes sure onFulfilled and onRejected are only called once. It makes no guarantee about asynchrony. Right? So we're going to ignore that component. And we're just going to look here about only calling it once. Internally, we had a function called resolve and reject. You guys remember it? It changes a state, it sets a value, right? That's what we had internally for the promise. Here's the problem. What if we call reject and then we call resolve? What happens? We changed the state.
Right, okay.
We changed it to being resolved, and then we took the error and we made it the value. You don't ever want that to happen. Right? Because after a promise is set as being fulfilled or failed, rejected, nothing else should be mucking with it. That promise is done. You can't go back and get the file from Bangladesh after you rejected it and you told the person that's using it that you couldn't get the file. That's what this does, right? This adds a thing in here called done, and it just simply says if the done flag is set, then don't change the other stuff. That's all this is doing. If done, return, otherwise set done to true and called unfulfilled. If done, return, otherwise set done to true and called rejected. That's all this guy's doing. Right? So this guy is just making sure we don't change the state more than once. Okay. So now we look at the constructor. We've already explained these three states up here, pending, fulfilled, and rejected. We understand that the state defaults to pending and then becomes fulfilled and rejected. We understand the value, no set to null gets set when you reject or fulfill. We understand the handlers. These are things that you call on success or on failure. And then here's the two functions, one that fulfills and one that rejects. And then we have this function here called resolve, and we explain what this does, right? Resolve is going to try under the JavaScript terms with this try block to catch the fart bubble. And if it does, it's going to process it under catch. And then we call this function here do resolve. Now this is the catch. The catch is that in this version of the promise, we're not calling resolve, we're calling do resolve, just to make sure it's only done once. And he could have done this a different way, that would have been easier, but that's how he's doing it. Right?
Yeah.
So now we're doing with this next one, what we're doing is we're slowly building it up, but notice how close to the bottom of the page we are. We've almost fully understood the implementation of a promise. And if it didn't click yet, you can go back and read it again later at a different time, and it should click. This is all that a promise does, right? So we have the handler, right? Handle. Essentially, this says if the state is pending, then we can push it. If the state's not pending, look what happens. If it's fulfilled, what do? We call handler.onFulfilled, which is this guy up here. And if it's rejected, we call handler.onRejected. So we only push to that list of things we do before the promise resolves. After the promise is resolved, we can't take any more handlers. So if you say promise.then or something of that sort, and the promise is in the resolved state, not the pending state, then there's nothing else the promise can do. The promise is done. So that's what this is doing. When you call something this.done, the promise is finished. That's all we're essentially saying here. So when the promise internally says I'm done, I'm in the state that is not pending. I'm in the resolved state or the rejected state. The promise says internally I'm in one of those states. There are no more things you can call on that promise. So we've done two things now. Just so we clarify. We can only change the state once, from pending to fulfilled or rejected. You can't go anywhere else after we get to one of those. And the whole idea that you're adding on to the handlers of that promise, after you hit fulfilled or rejected, you're done adding on to those handlers. So that's it. That's what a promise does. All right. So now we're going to go through the book, and I want to hit up and show you some of the things that the book's got. And we're going to see how far we make out of it, and I'm going to skip over a lot of the book's hairy details because they're not related to the synchronous program. They're related to application stuff. So the book has 3 different little graphs here: synchronous single thread of control, synchronous 2 threads of control, asynchronous. We had this word parallel mentioned before in the class, and we had the word concurrent mentioned in the class. This asynchronous at the bottom is concurrent. When we call these things, they're out of order, right? Notice how these are in order. This is in order. First dot, second dot. This here, they're both in order too. We call them both at the same time. We wait for them both to finish. But this one, we're actually concurrently doing 2 things at the same time. We're doing waiting because there's no blue line. That's what that means with these graphs. We're waiting, but we're waiting for 2 things concurrently at the same time. So that's what they're trying to show. They're trying to show the difference between parallel, synchronous, synchronous without parallel, and asynchronous with concurrent methods of processing. So here we have a very simple set timeout. right? Let's come back here and we're going to run node. Boom. Okay, well. You can see here, if I run it, it's returning something really goofy. But the point is that it will eventually come back in 5 seconds and it'll say tick. See that?
That's covered under changing the file.
So I'll do it again, watch. We're going to ignore part of it, because all of that stuff is just, that's how a promise looks, right? But then it says tick. Right? So that's what they're showing here. They're showing you this is a method of writing asynchronous code. With this function set timeout, we can provide any callback as the first argument, and then the interval is the second argument. And then after the interval expires, this timeout expires, it's going to call this callback function. Set timeout is a core function of JavaScript. Okay, so let's look at this. Here, we're going to go through this. We're importing a function, big O, from ProTech. Right? We went through imports earlier, and we only showed this method. This is the newer method of doing an import in JavaScript. You guys remember, I don't know if anyone read that chapter outside of the class, but we only covered this method in the class. Right? So this is looking for an object from this, and it's going to pull out only the big O method. And then what we're doing here is we're saying the big O dot read storage, right? This function object, big O dot read storage, and we're going to provide it this name of what we want it to read, and this, the callback, right? And then what we're going to do is we're going to look at the result, because the callback takes this. This is the argument, right? The thing to the left of the fat arrow is the argument. The thing to the right of the fat arrow is the body. Just to recap on that syntax, the argument is caches. We're going to look at the first argument, and we're going to set that equal to first cache. Then what we're going to do is we're going to call bigoak.readStorage again, and we're going to look for whatever thing we got. That first argument, first cache. And we're going to say, when we find that first cache, right, I want to call this function now. Remember? Another callback. So now we're 2 layers here. First callback, second callback. See how we have 2 different indentation levels there? That's how callbacks work. Now we're going to call this callback. And we're going to say essentially, whatever we provided, info, we're going to console that log.
What would be required to turn
Evan, is the fat arrow syntax, is that?
So you have to
Propagate that error up. You have to do that work if you're using callbacks. With promises, you don't have to do that work. And async await just reflects it to the user. That's why everyone likes async await.
And async, what was you said, an async await does what's right in here.
Propagates it for you to the user. Reflects that ability to the user. Promises give you the ability. Async await is just a thin little veneer over it. Right? It's a thin little veneer, and let me show you how powerful it is. It allows you, and I am too stupid to manage tabs today.
You have so many tabs.
You have like
Look at
37
that.
tabs open.
My MacBook cannot even handle that.
Okay. To the life, I had no idea which one I was on. Okay.
Means you read a lot.
This is the I know that wasn't I on like I don't know where the thing went. Okay, let's just open it up again. Oh, there we go. This is where I was at. Okay.
Found it.
So, look here. We were at the async await thing here.
How do you flip through the tabs in Chrome?
Control page up, page down. Okay, look. So this is their example, right? I just wanted to show you here. This is an example of async await with try catch. Let found equals await route request, right? Route request is returning a promise. Await is going to say when that resolves, set it equal to found, and enter the code again. Start here. If there's an error, you can just catch it with a try catch block. You can have let found equals await router request, let next equals await, you know, whatever else. You can just chain it. So you have the ability to write promises, and async await allows you to make those promises look like regular synchronous code. So this method here, let found equals await, right? This allows you to write code just like you were writing PHP or Perl or Python. You no longer have to worry about promises or callbacks. And you can still do the same error catching goodness. That is the ideal situation. So you've seen now, the book wanted you to go through the whole path of figuring it all out. You start with these thenables, then you start with callbacks, then you move to these thenables, then you move to the promises, you know, then you get to async await. And now at the point that you get to async await, you just say let whatever variable equals await, and something that returns a promise. And you can do that through and through. So you could say something like this. You could say let file equals await fs.openFile. Right, now if it goes to Bangladesh, it doesn't matter. When it comes back, it sets the value equal to the file. It sets file equals to that value, the file handle. Then you can say let line equals file.readLine. Right? And again, if it has to go back to Bangladesh, your program is doing other things in the background. When it comes back, it hits that await. And then it moves on to the next one. You know? And you can write all of this code like this, and it all happens in an event loop seamlessly. Okay, so the important thing is, this is the future of JavaScript. This is pretty much where we're at. I write code just like this today. A lot of people do too.
Learn every day for something.
And I think there's some other good things here, but I don't think that we should be worrying about all of them. Let's take a look at this asynchronous bugs thing.
Do it. That's what my sound says. Let's do it. Let's do it. Let's do this. Let's do this.
I want to go over one more thing here. This is kind of cool.
I like cool.
We have this here, promise.all, right? Promise.all is really cool. Because promise.all, this thing right here, this is going to take an array of promises and run them all at the same time. So one of the promises we did was making the request, that web request. That's making one web request at a time. You can actually make 4 or 5 web requests at the same time. Your computer will send them all out and wait for them all to come back.
Do they all have to come back before they're resolved, or can you resolve one at a time? You can resolve 2, and you can reject 3.
They all have to come back. There are ways to get around it. The promise.all will wait for them all to resolve. Because what it's going to do, and promise.all will return its own promise, and that promise has to have one of 3 states. Right? So it's going to have the state of resolved or rejected, and when it has that state, it's going to call the handler with all of the results.
Just can even after, let's say, 2 of, or let's say 4 of 5 things in the array are resolved, the status of the promise.all is still pending until the last.
Lately, I've been getting all the time. Like how the was is.
So if you want something more sophisticated to handle that problem, you're talking about, you can look at something called Rxjs, which we sadly won't be going over in class today, but it is truly amazing. Because promises can't do something here, right? The promises have some shortcomings. They are truly amazing, and they keep everything dirt simple. So async await was something that I believe was first implemented in C#. The C# programmers brought it into JavaScript. It's great. There is something called the Rxjs, for the reactive extensions to JavaScript. Promises cannot be retried, right? So there is no easy way to say if there's a failure, retry the promise. Retry the chain or retry the part that failed. You don't have the ability to do that. You also don't have the ability to allow multiple people to subscribe to the promise. A promise is a sequence of actions, right? From the top to the bottom. But what if you want to have 3 people receive the same action? Let's say that you're writing a chatbot, for example, And one of those chat bots has a client that's a web page. So you want to be able to see what people are sending you on the website. But then you also want to create a client for your chat bot that's going to tell your like desktop manager, your Windows thing. It's going to pop it up there too, right? You can't tell with promises, I want 2 people to be able to listen for this.
So what's the solution?
Rxjs. Rxjs is 1,000 times. There's a great book for it called Rxjs in Action. It is really, really cool, but definitely that's the way that everyone's going with it. It's a lot of features that promises don't have.
So that's just another way to do promises?
No, that's a lot more complexity. They have to go on their whole class. But here's the thing. Rxjs will do everything promises do and better.
So it's funny that in the beginning of the class we had, we're like on our 4th version of all this. Like, what was the first thing?
Callbacks. Callbacks, intervals, promises, async await.
Were you talking about
Okay.
functions versus bad arrows?
No.
Like talk about bad arrows.
I'm just saying that, like, promises was the solution to everything a minute ago. Now there's an even better way.
Oh, yeah.
There's always something that tops it up, huh?
It's a lot of it is about like what you need to do and what you need to get done.
Right. So a callback still might be useful in some circumstances.
Callbacks are certainly, they're everywhere in JavaScript, right? So high performance libraries are still callbacks because that's still the fastest way. There's no state. There's nothing modifying state. So if you're going to send 10 million of them, you don't want to update 10 million variables, maybe. In JavaScript, it's pretty damn fast, and language, comparatively, it's not going to make too much of a difference. But yeah, you have a lot of things that are high performance that still stick with callbacks. You have a lot of things that are exposing promises because it makes it way easier for a programmer to catch errors and chain things, sequence their stuff. Then you have a lot of people moving on to Rx.js when you need it. If you're going to make a web server, Rx.js is the way to go. If you're going to use Angular, by the way, if you're moving into the Angular React world, Rx.js is a technology that's in both of those. The whole thing is that way. So you can have like multiple different little components, is what they would call them in Angular. And those components can all subscribe to the same database. Right? If it was a promise, you can only have one component called that on it.
For some reason, this JavaScript book from 2006 doesn't say anything about promises.
That book is very useful if you want to learn the language, but it's not useful at all for becoming a JavaScript programmer.
Okay.
So that is almost, I mean, I'll take it if you don't want it, but it's almost trash.
No, it was on the shelf back here.
I see, almost trash.
Almost.
Yeah.
It's like edging it to me into the trash can.
No,
So
what-
JavaScript has a lot of stuff. So it's like this book is JavaScript the Definitive Guide. Is that the one?
Just the one up. Yeah.
JavaScript the Definitive Guide. Okay.
It's
I've
never
heard
too
this.
definitive.
Half of this book is no longer there anyway, right? So
It
if you
was
like
not
look into
that.
this book, you'll find that a lot of these features in this are simply they're just archaic and they're really cute. They're really weird. But if you hear someone like shit talk JavaScript and you want to understand it, that's the biggest gain you'll get from this. You know?
Right.
You can understand a lot of like the design mistakes or.
But I don't want a history lesson on JavaScript. I just want the current useful information.
This is definitely the history lesson.
Yeah.
Okay. Anyone have any questions? All right. Cool. If anyone has any questions about any of this asynchronous stuff, I know it's deep. Then give me a shout. If not, we have two options, and we're into taking input on either one of them. This is the big where do we go from here question. One of the places we can go from here is Python. The other place we can go from here is client-side JavaScript. I'm still up for both of them. The deal with client-side JavaScript is I don't think if we run that class, we keep going on with it, we need to make sure we get another 10 people in on it. Because that class, like this class, you can see the empty seats, we have 1, 2, 3, 4, 5, 6, 7 maybe.
They got exhausted.
We were standing room with the first class. We're now like, let's say 10 classes into it. We've done a lot, but we've lost, 7 people. I would expect the same thing to happen if we're going to go through the whole browser nonsense. There's a lot of stuff that's pretty nichey too. Like things that are only helpful in certain circumstances. On top of that, the deal with JavaScript is no matter where you are, you're being a computer programmer, that state and set that value. Okay. All right. So,
Oh, sir.
yes.
The states you talked about, that, be typical if there's still any promise has to have just at least 2 states.
Right.
But you can have many more than that.
No.
Oh, just okay. All right.
No. As
Sorry,
far
I
as
thought you were.
I know,
you were.
there's a spec for this called A+ that most people follow. Promises in other languages could mean other things, but in JavaScript, if I recall right, there really are only 3 states. And this is not very complex. It's pending, fulfilled, or rejected.
Okay. Is reject, is that for catching an error, reject?
That's exactly right. That's exactly right. It's that simple, guys. If the state, if you call that function we just saw, right, reject, you're providing it the error, and it's setting the state to reject it, and it's setting the internal value to that. That's what your error catching mechanism is going to catch. It's going to catch. Okay. So, what we're doing here now is we're laying on top of this. All of this stuff is the same. One thing is now changed. That's this guy right here. We have a function now called resolve, right? Let's look at what resolve does. Resolve takes a result, and it essentially has a try-catch block. This is how we went through this earlier. We showed how JavaScript catches errors and how you handle errors in JavaScript. Does anyone recall this?
Rings a bell.
Rings a bell. What does try do? Does it ring anyone's bell?
It tries.
That's really good. You know, it's not bad. We may have to work with it. Does anyone want to try taking try a little further?
Try it out.
You're essentially testing what's being executed.
It's evaluating that.
JavaScript may run something that you don't want, and a try catch block kind of helps catch things that you don't really want to see. You can kind of create your own.
Does
error.
anyone remember?
Is it like if else?
No, but you're actually very close, right? In fact, I would say that you're right. I'm going to explain it a different way, because I made the example that everyone laughed at, but it was somewhat comical, about catching fart bubbles, right? You don't always want to do it, but you can do it. That's what that does, right? If we don't catch this shit, it's going to bubble up to the top of the jacuzzi, and we're all going to have to deal with it. So try catch is our mechanism, right, of catching the fart bubble. That's the thing that we don't normally want. That's the error, right? But we can catch the fart bubble with the try, and then we can handle it with the catch, right? So, you know, pass it on to the girlfriend or whatever you got. That's where you handle that with catch, right? So what you do here is you're stopping that error from propagating.
New way of doing it, or an older way of doing the anonymous function?
I mean, for JavaScript, it's an old way, but it's certainly a newer way than, you know, the other ways.
Okay.
The Fat Arrow has probably been in there for maybe 4 years, maybe 5 years.
That's pretty new then.
Yeah, except for JavaScript. We're literally everything changes every 10 months. Okay. So, this is what we really get. This is pretty easy, right? We're calling bigoak.send. We're providing it the name of whatever we're sending, what it is, and then something, the content of the message. And then we have this callback, right? This callback accepts no arguments. That's what the empty parentheses mean. All it does is says console log note delivered. So when we get this callback triggered, we know the note was successfully delivered. Whatever time that callback hits, that note is done. Okay. Now, we have this last one, import define request type, right? And I don't think define request type, yes. So this isn't actually in the text.
You can't do this with Notepad.
We've done this before where we look into the code samples in the book. So here's where define request type is. Define request type. Nope, that's not actually it. Protect.define request type. Protect. There we go. Okay, so this is getting a little, this is why I'm saying, this is why I really hate this book. At least I hate this type of stuff this book is doing. This is where define request type is actually defined. The book doesn't even mention this, right? It doesn't show you the implementation at all. But it's in this thing called network, and here it is, and it's taking a name and a handler, and it's adding the name and the handler to the request type. So it's telling it something about what we do when we get that request. So we're saying when we get a request called note, this is how we handle it, right? So we're defining a request type note, and we're saying when we get a request note, we do this. So previously, we've always thought about callbacks as something that we do when we're done doing work that we want done. But that's not the only way to think of a callback, and that's perhaps useful to think of it a different way, right? Here, we're defining a request type. And what this is going to do is it's going to call our callback whenever we get that request. So if I say ping, you say pong, the work is done, right? But now you've set up a server, and you're waiting for people to tell you ping so you can respond with pong, right? So he's building a server here, and he's saying when this server gets a note, do this, right? That's how we think about that. He's not doing something. He's
Waiting
saying
for an answer.
He's waiting for that request. He's waiting for that answer. Okay. Promises. I was introducing them. So promises here are stupid because you'll never see this. Promise.resolve is something you'll almost never see. He's resolving this thing instantaneously.
Say that again.
The whole promise.resolve thing that he's got here, right? You will almost never see this. Promise.resolve. Promise.resolve creates a promise that resolves it instantly. So that's all that does. So I'm saying that I've never seen that in my life. I know it's there, but no one uses it.
Try to defend yourself with no plan because you like a football.
Okay. So now we're doing is we're creating a promise-based implementation for read storage. He's showing you how it works, right? So we have this thing here called storage, and it's going to take a nest and a name, and what it's going to return is a promise. We talked about, you asked the question, Dan, about when we actually use promises, and I told you you would use them if you were creating a library that made promises. This is an example of creating a library that makes promises. So this library here has a function called storage, and that function storage is creating a promise. It's returning a promise. So I said when you're using a library that already does the work for you, you use then and catch, and that's pretty much it. When you create a library that's returning a promise for someone else to use, you're going to use this method, where you return the new promise. Right? So that's the example of what it looks like to actually create the library. And what he's doing here is he's saying create a new promise that takes resolve callback, and it returns nest.readStorage with name and results resolve. So you see here we have a nest and a name. That goes right here, nest and name. And I know that this is kind of complex, but this is how we actually create a library that uses these promises. That makes these promises. And here's how it looks. If you do that, then this is how your users would interact with it. They're going to call storage. They're going to provide it. The nest. You see up here we say nest is the first argument. The nest is big O. And the name is enemies. Right? So that's how that works. That's how we create a promise for other users, and that's how we call that promise. So storage is returning a promise. It's taking a big O and a name, enemies, a nest and a name. It returns a promise, and then we can call then on it. Does anyone have any questions about this?
Good.
No. Okay. So we talked about failures, and we saw when we failed, we saw internally when we call resolve, if we fail in that try-catch block, we call that reject, right? Let's go back to it, and I'll show it to you again. You say right here, look, resolve with result, but if we try it here, and we have an error, we call reject. See that? So when you make a function, when you make a promise, one of the things that that promise takes is it takes the reject and result handler. Reject and resolve handler. And if we call the reject handler with the error, then what it's actually going to do is say, for each handler, call the second argument in, right? Because the handler has a reject and a resolve in it. It's going to call the second argument, which is the rejection. It's going to set the value to error and call the second argument with it, right? So what we want to do is we want to look at this. This is the method here that we're doing. Let's see if we have a simpler version up here. Here, unrejected reason. That's what we're doing with the do resolve thing. We're calling this unrejected and providing with the reason. So when we see this here, what we're doing is, look here, this is the handler right here. See this? This is one example of a handler. This handler takes two arguments. It takes resolve and reject. Now he's using an underscore for resolve. He's not even writing the name here because he's showing you he doesn't do anything on success. This promise only handles failures. Negative promise. That's what he's doing. Only handles failures. So what we're doing is we're saying when we reject, call the reject function. This promise takes two arguments, resolve and reject, but it only looks at the reject argument, and if it fails, it calls the reject argument with new error failed. So then we say then value console log handler 1, and then we say catch, and we do this printing out thing. So you'll notice we never see handler 1 called. We never see handler 1 called. We don't see this message here. We don't see this message here because we never resolve. This is a then, so we go straight to the catch. This is what it's going to look like when you're writing code that uses promises. We have this, then this if it's successful, or catch. Right? So we're not successful. So we never print out handler 1. We just go straight to the rejection. And this is what the rejection handler does. Takes a reason and it says caught failure plus reason, return nothing. Caught failure, error fatal. The error is part of this. And then it says handler 2 nothing. So this is how promise code will look. Then catch. Catch is the fart bubble thing, right? So that's what we got. So if you write that catch statement there, that exception doesn't go to anyone else. You handle this. And the cool thing about doing it this way is you can chain all your stuff together. Go to Bangladesh, get my file, write to my file. Open up my second file, write to my second file, and then catch. And it'll catch errors in any step of that chain. You can handle them anywhere. You can also write, do this code like this, then catch this, then do this. And the reason why you can do this, look at this. Notice how catch is not at the end. Right? Why is catch not at the end? Can anyone take a guess?
Because you want to catch, if you catch it, you want to do something and not let the rest of the code run.
Not just that, but also if you catch the error here, you know this error, this was not what created that.
Oh, okay, yeah, okay, yeah, go. Okay, yeah.
So you can catch it any step of the chain. You have a chain, and you can either look at it, you start from the bottom or you start from the top. Everyone look at it. You're starting from the bottom of that chain, you can put that catch link anywhere. Right? So if you're catching it in the middle of the chain, you're catching everything below it to the starting point. If you catch it at the very top of the chain, you're catching everything that could have possibly created that error. So he's putting this catch in the middle of the chain because he's got two then blocks, right? So this could create the error, or this could create the errors, and this catch will catch it. You guys can see how this is kind of complex, right? The only thing you got to remember is the catch and the then. But this is one of the reasons why synchronous languages are easier to understand. Python, Perl, Ruby, PHP, they're easier to understand because JavaScript is an asset. You can use Node on the server. You can use Node to download websites, to process files locally, to administer your computer. It's good for all of that. It may not be the best, but it's good for it all. If we do the browser stuff, It's only going to be a subset of you guys that are interested in web development, right? So my big concern is that we're subsetting a group, and I got to make sure that we can grow it to fill it, you know?
I would have thought that the subset would have been, what would you call what we've been doing already, more of a server side? I mean,
No.
we've been digging into the language itself without thinking of where it's going to.
Fundamentals. You guys have the foundations for being a JavaScript developer. I mean, if you've been following along with this book and you think you can actually manage this book by yourself, I think you really have what it takes to go and become an entry-level JavaScript programmer in different capacities. You may have to learn the DOM yet, but you know variables, you know looping constructs, you know how to integrate with modules, you know how to download packages from Node and NPM, you know the basics about asynchronous programming and event loops, you know class syntax, you know coroutine closures, you know the anonymous function syntax and the function syntax and object literals. We talked about some functional programming with MapReduce, with for each. We went through all of the functional stuff. I even showed you some Lambda. We went through Rxjs, covered them thoroughly in 2 days. Went through grep and vim. We went and really laid the foundations for what I believe you need to do to become a programmer in any capacity. But we applied it all with JavaScript because this is what's hot today. You know. So to answer the question, this is the superset. You don't know this shit, you're not going anywhere. You know this shit and you're good with it, you can go somewhere. And it doesn't have to have anything to do with web development. All right. So yeah, get in touch with me if you have an opinion one way or not. If not, I think maybe we should prepare for a Python class. But that's my own, because I'm concerned that I can't fill these seats with JavaScript browser.
I would imagine that JavaScript.
Of asynchronous frameworks, loops, callbacks, promises, async await, none of that is there. Okay. So, I think at this point he goes really into the weeds, and I don't think he's explaining much more about it. I'll be honest with you. I can keep going if anyone wants me to keep going. Pretty much at this point he's showing an application. Right? So what I want to show is one more thing. I'm going to skip the application. We're going to skip message routing because I don't think that's important. That's all his application. Unless anyone wants to see it, you know, we can go over that too. But I want to cover this here, async functions. Here we go. Okay. We have this thing here called load URL. Let's make that a little bit bigger so you can see it. I just grabbed this example from javascript.info. This thing is called load JSON. Load JSON takes the URL, and then it calls this method called fetch. Fetch returns a promise. We saw how to implement something that creates and returns a promise. This is what fetch does. This is how you, as a user, will be interacting with promises. We call fetch and then we call them. That's pretty much all you got to do. That's how we would interact with a promise. And this is very close to an actual JavaScript framework request, right? So we're saying then response, and if response.status equals 200, we return response.json. Otherwise, we throw a new error. Response.status equals 200. That's just the HTTP status code for success. Right? So when you're writing an HTTP client, you're making a request to a web server. If the status code is 200, it's success. Anyone here know what 404 means? File not found. Right? So that's a status code too. So everyone knows 404 is file not found, but if you're a programmer, you know 200 is success. Right?
If you get 500, that means you didn't write a catch.
If you get a 500, it means server error. Right? So a 500 means there's an error on their side. A 400 means there's an error on your side. You made a request for something that doesn't exist. If their server dies while answering that request, it returns a 500.
200, you're good.
200, you're good. Anything in 200s are good. They're all based on hundreds. 200, you're good. 400, your error. 500, their error. Those are the big ones. Okay, so then we load the JSON, and this is how we're doing it. Now look, we call our function load JSON, and all we do is we catch, alert. Right? So we're saying if we catch an error, alert the user. This is just what the promise looks like. Now I'm going to show you how we would do this today.
Yeah.
It's that simple. This is how it would look today. Async function. This is the keyword. We put this right before the function. Right? When you put this before the function, then the function returns a promise. All of the work is done for you.
Sorry, we could have skipped to this step right from the beginning.
You're right. You're right. I'm like split because
I'm just
through the
messing with
bushes.
yeah, it's a really difficult thing. Like, how much do you actually want to teach, right?
No, you
No,
did a
that's
good
good.
job.
Okay.
It's there.
Yeah, I do want to get to it and show you how easy it is, so we don't scare everyone off. I think it's important.
Everybody's gonna go
So-
happy and smile.
That's right. So async function just takes care of creating the promise for you. Now look here. What we do here is we say await fetch URL. This is really cool because await fetch URL, all this does is it says if this promise resolves successfully, put the value in response.
Huh.
Now what happens if the promise doesn't resolve successfully? It can have two states. One of them is resolve, the other one is reject. If the promise rejects, it throws a regular error. So you can actually catch it with a try-catch block, just like a regular fart bubble. So that's the advantage of the try-catch with async await. Await expects a promise, fetches a promise, right? It tries to store the result of the promise, the value, in a response, and if it errors, you can catch it with try-catch. Rewind a second. Rewind, because if that doesn't sound cool, we gotta go back and we have to hit this one more time. We talked about
Hit it with the machine.
the callback hell thing. Here we go. Look here. Callback hell. This guy, horrible. Why is it horrible? Because this is how we're doing the error. If error, console log this, right? So we're expecting this guy here, this error thing somewhere, function error value. That's the callback pattern. We're expecting this to be an error, and then we have to check to see whether or not it's an error. Error catching in this requires you to check every callback for an error in the callee. The callee checks the callback. The callee of that checks the callback that it had, right? So from the perspective of catching an error, you have to be in this to do it.